In this video, we will do prime numbers, prime factorization, and index notation for elementary mathematics, Sec 1. Prime and composite numbers. So let's start with a prime number. What is a prime number? It is a whole number that is greater than 1 and has 2 factors. So for example, let's take 2. So it has 2 factors, 1 and itself. So this is a prime number because there are no other factors. Let's do another one, 7. 7 is a prime number because it's 1 and itself. What about 6? Is 6 a prime number? No, it isn't. That's where we start with composite numbers. So if they are not prime, they will be composite numbers. So 6, we have 1 and 6. Yes, that's true. But we also have 2 and 3. 2 times 3 gives you 6. So this is a composite number because it has more than 2 factors. Like 1, 2, 3, 4. So let's have another composite number. Are you thinking what I'm thinking? 15. 1 and itself. 3 and 5. Oh no. And then it's 5. So it also has 4 factors. So this is a composite number. Now let me show you other prime numbers. This is a list of prime numbers from 1 to 100. So we are going to focus on 2, 3, 5, 7, 11, 13, and maybe sometimes 17 and 19 for the really tricky questions. So there is a pattern to numbers, and if you look at this, the ones, 3s, not all, yes, not all, 7s and 9s are kind of prime numbers. Not all, but some. So more about this is that 2, 4, 6, 8, and the 10s right here cannot be divided by 2 because they are even numbers. And the 1s, remember, 7 times 3 is 21. Gives you a 1 at the back. All these can be divided by either 3 or 7. This by 3s. And 7s, yes, but it is 3 times 9 is 27. And we have this 9s here that can be divided by 3. Let's try a quick quiz. You can do it together in your exercise book. Now here's the one. Name 5 prime numbers. Alright. 2, 3, 5, 7, 11. Do you name more? 13, 17, 19, 23, 29. Did you list this or did you list something from the grid? Let's name 5 composite numbers. Let's see what comes to mind. 10, 12, 18, 15. Anything else that is not a prime number? I like 24. A lot of factors. 25, 26. So many. Did we get the same numbers? Now we are done with prime numbers. Let's go on to prime factorization. Let's start with prime factorization. So if we have 6, 6, what are factors of 6? Let's start with 1 times 6. Now, when we look at this prime factorization, 6 is not a prime number because it's a composite number, and 1 is not a prime number because remember that prime numbers have two factors, 1 and itself, but 1 just has 1. So now we have 1 times 6. Let's try another one. 2 times 3. So if we look at this, it would be 2, okay, which is a prime number, and 3, it is also a prime number. So this is prime factorization. Factorizing it, finding the factors of 6 using prime numbers. Alright, let's try something a little more complicated. Let's see. Let's use 12. Many factors. So let's try this. 2 times 6. So 2 times, you look at this. This is 6. What is 6? Right here. So 2 times 3. Let's check back. 2 times 2, 4. 4 times 3 is 12. Yes. So we have it here. Now, 2 times 2. So same number, multiply same number. We can write this as 2 squared times 3. Now, this will be presented in index notation. So these are the prime factors of 12, 2 and 3. So there'll be 2 2's and 1 3. Let's try another one, which is 18. So we have, let's say 2 times 9 is 18. Alright, 2 times, what is 9? 3 times 3. So we have 2 times 3, 6, and 6 times 3 is 18. And so now let's write it in a shorter way. 2 times 3, how many 3's are there? 2. So we have 2 times 3 squared. I have a question here, and it's prime factorization. Express 90 as a product of its prime factors. So the first thing to do is that we need to find factors of 90. So what we can do, this is the first method, which I really don't recommend, but I'm going to show you anyway. So 90 is made up of two factors. I mean, there are more, but you know, something times something is 90, you know. So let's do 2. That's the easiest because it's an even number. So 2 times 45 gives you 90. Alright. And let's go on. So we copy 2 down, and 45 is made up of 3 and 15. Why do I do this? Because 3 is a prime number. So I take out a prime number from 45. So a prime factor from 45 is 3. And the rest goes into 15 right here. So moving on, we have 2 times 3. Okay. And what is 15? 3 and 5. So when we look at this, all of these numbers are prime numbers. So we have our answer. I'm going to show you the other way, which is this way. I do this way. Okay, so we have 90 and we divide it by 2. So it is 45. So when we look at this, 90 divided by 2 gives you 45. Let's do 45, so it's 5 and 9. So you divide it by 5, you get 9. And 9 divide by 3, we get 3. And another 3, we get 1. Let's stop when we have 1. So there we have it. Why I like this method better is that it's more compact in case you, like most of the time we don't have enough space on our worksheets. So yeah. This one tends to spread out quite far. Imagine if you have the number 1250. It's gonna go like a lot further. So this one, I prefer it's compact and it's pretty fast. So alright, let's write down our answer, 90. And let's use index notation. Okay, so what I like to do is 2. I'll just mark this out. 2 times, there are 2 3's, so 3. And I will arrange it in order from the smallest to the largest. And we have 5. 1 5, like that. So we have a question here, very exciting. Okay, let's try this. 140. So we're 140. And we can start by 2 because it's an even number. So it's 2, 70, 2, 35, and we need divide by 5 because there's a 5, so that's easiest. 35 divided by 5 is 7, and we have 7, 1. Alright, so 840 is 2 square, and we have 5 and 7. So I will arrange it from smallest to largest. We are going to do a quick quiz. You can pause the video and try in your exercise book. Here's our mega question. Express 1575 as a product of its prime factors. So it is a mega question. In the thousands, please. But let's try this. So we have 1575. And it's not an even number, so we won't use 2, but there is a 5. There might be 3's, but there is a 5, so I'm just gonna head straight for the 5's. So it's 5. So I'm gonna divide 15. 5 divided by 15 would give you a 3. And then there's no remainder, so there's 7. Doing some quick math, so it's 1. 1 5 can go into a 7, and there would be a remainder 2, so 225. So there will be a 5. Do another 5, where we have 6, which is 30. 5 times 6 is 30 for this. Left 1, so 15, and we have 3. And then we can divide by 3 because 3 and 6, or 6 and 3, we have 21. 21, we have a 3, which gives you a 7. 7 gives you a 1. Alright. There we have it. So let's express this. 1575. We have 2 3's. So 3 square. And then we have 2 5's. 5 square, and then we have 1 7. There we go. Did we get the same answer? We are done now with prime factorization and index notation as well. In the next video, we will be doing highest common factor and lowest common multiple, HCF and LCM for short. Do stay tuned. Do like and subscribe, follow, and if you have any questions, do leave them in the comments section below.